All right, ladies and gentlemen, let's kick this off with a thunderous applause for Mad Science.
Thank you very much. Thank you. How many of you have heard of Mad Science before? So a few, yeah. How many have children or grandchildren that have participated in our programs? All right, well, it seems like we need to get the word out, so that's why I'm here. I'm here to get the word out about our program called Mad Science. This is a huge corporation. We have one office in Sacramento that takes care of elementary age students in a multiple range of schools, from homeschooling to Montessori schools to regular elementary schools in 8 counties in this area. So we have amazing instructors that go around from school to school, and we teach science in these after-school programs. We have a huge warehouse of equipment and supplies and materials to give these children a real hands-on view of science. It isn't just standing up there talking. We give the principles, but then we make it fun. We let them blow something up or light something on fire or build something, create something. We do birthday parties too. I told my son that. I said, yeah, I'm a scientist, which I actually am a scientist. I'm not a doctor, but I am a scientist. And I said, now I do birthday parties. And he said, so what are you, a science clown? I said, well, I guess, but we teach the kids scientific programs. We have a laboratory. The kids can come to the lab for the birthday parties, or we come to your house, and we show off the same kinds of principles that we would in the classroom. We talk about air, we talk about gases, we talk about illusions. It's a huge array of science that is fun and interactive for the kids. So I'll give you a little demonstration about how I would start a class, and you all are going to get to participate. So I'm Dr. Neon. I'm going to be your instructor for today. So let me ask you a couple questions. Who likes cake? Who likes candy? Who likes rules? Oh, yeah. Well, you know, some of us don't like rules. You know, but rules are very important. They keep us safe. They keep us together. They keep us unified. They give us a sense of balance. So I have 3 rules for you for today before we start our program. So I want everyone to pick up their number 1 finger, probably the one you picked your nose with this morning. And I want everyone to say rule number 1. Rule number 1 of mad science is no talking when the mad scientist is talking. Because if you're talking and I'm talking and you're talking, what are we not doing? Right. So I want you to hear what I have to say. And if someone has a question, we want to all hear that question. So that's rule number 1. So now I want everyone to say rule number 2. Rule number 2 is don't touch my stuff. I have stuff. I have stuff. I have stuff. Some of our stuff can be dangerous. Who can tell me why I don't want you to touch my stuff? With a quiet raised hand. Anyone? What do you think?
Because you pay for it with your own money.
Well, you buy it. So you might pay for it if you, no, we don't do that. No, the reason is for safety. We have programs that get the kids' hands on things, but we never give them anything that is going to be dangerous or unsafe for them. As scientists, we are trained with the different chemicals that we use. In fact, I've heard that if you take all the chemicals that we have in our warehouse and mix them all together, you could blow up the world. And we don't want to blow up the world, do we? All right, so the number 3 rule of mad science, I want everyone to say rule number 3.
Rule number 3.
Rule number 3 is that we have to have fun. We want to have fun. That's the whole idea of mad science, is to have fun. So on the count of 3, in your loudest outdoor voice, the one you never get to use indoors, I want everyone to shout, have fun. Are we ready? 1, 2, 3, have fun! Oh, that was kind of weak. Let's try that again in our loudest outdoor voice. 1, 2, 3, Have fun! Okay, so that's what we're going to do today. I have a little experiment to show you. I said we got to blow things up. And we are. So, always we wear our safety protection. And I get to use chemicals. Flammable chemicals. So I'm coating the inside of this very special Mad Science bottle with a flammable liquid that as it coats, it's going to give off a gas that is hopefully going to give us a fun experience. Any smoke alarms in the vicinity? All right. Maybe I should have saved the 1, 2, 3, have fun for this moment, huh? Fire. Are we ready? Thank you very much.
One more time for Mad Science. And I'm glad to be alive. So we're all here celebrating Darwin's birthday thanks to a tremendous effort by a lot of people, but I want to bring up one person in particular, sort of the mastermind behind the last, 20 years, I'm going to assume, of Darwin Day, certainly quite a while. Let's all give a warm welcome to Minga Fratelli.
Hi, welcome to all of you, and thanks for coming out on a sunny afternoon to celebrate science with us. As he said, this is we've been here at it a long time, and this is the 20th annual Darwin Day Fest. It's an educational gala. We like to think that you're going to walk away knowing something that you didn't know when you walked into the room. So we're pleased that you came indoors for that sunshine, because I know it's tempting to be outside after our monsoon season. You've already seen that we want to do a bit more at this event than just have a serious science presentation. We want you to have a little bit of fun, not only with Mad Science, but with the videos that we show and the merchandise that we sell and the refreshments. And by perusing those evolution cartoons, if you haven't seen those, along the wall. And if you visit that sales table over there, you can look over Darwin Day, related merchandise that you could wear or maybe put on your car. We like to end up this gala by showing our appreciation for Darwin's big idea and reaffirming the momentous idea that he had by eating up his birthday cake. So stick around for that part. And also, if you haven't visited all the tables, please take time during the social session to visit those and chat with fellow fans of science. We're here to educate, and we will do that through our speaker presentation and also through what's at the tables. But it's important to recognize, and we do, that science really does belong to everybody. And Darwin has become a symbol of scientific advancement that can and should be promoting a common bond among all the Earth's peoples, and not divisions over ideology that continues to impede educational progress in science. I'm extending this welcome on behalf of all of us on the volunteer organizing community. You'll see our names listed inside your program, along with many and not all of the folks who showed up just today to help us with assistance in putting on the event with the audio and the video, refreshments, admissions, cleanup, if any of you are interested. And at this point, I usually name those individuals and tell a little bit of what they do and wait for the audience to applaud them after I've gone through all of that. Well, this time I'm going to skip that because I have something more important to say, and I only have a certain amount of time to say it. So I'm going to ask all those people who helped with today's event, just stand up and we're all going to applaud you right now. You're out there. Okay, this year is different. I want to save a little bit of time, and I have just a limited amount to ask all of you to think about some things. One is the people that put on the event. Who are we? We're just simple local folks who really love science, and we like to toast it now and then for the benefit of all humanity. We've been doing this, as he said, since 1998. This is my 19th year at having involvement. And we were one of the first groups to do this in the nation, but now it's happening all over the world. There's lots of other annual events that commemorate Charles Darwin's birthday and mark in some way his superb contribution to human understanding, or simply to the value of his idea of natural selection. It was daring in his time, too little understood, and controversial even to this day. Nonetheless, that 19th century dangerous idea has, in its refinement and development over time, had a permeating effect on our lives today in so many fields of science and all across the world. In celebrating the life and legacy of Darwin and evolutionary science, there are lectures, sermons, there's museum exhibitions, film showings, parties, more. We just learned this week that a game design studio at the University of Idaho, it's one that uses evolutionary principles to build better and better video games. We'll be releasing a brand new game tomorrow called Darwin's Demons, and you can check it out on Google and find out what it's about. It offers a unique approach to getting across to the public the nitty-gritty of natural selection and adds a distinctly modern and nod toward Darwin's own revolutionary publication in 1859, The Origin of Species. All these varied events and products help somewhat to remind the public of the benefits of science, but it's not enough. Typically at this Sacramento event, I go into reminding everyone about the contemporary scientists deeming of Darwin's as the most powerful scientific theory ever developed, and how the fellow himself was and remains a scientific giant. But I'm cutting it short, and I want to go on because these days it is important that we not only celebrate science on Darwin Day, we've got to start protecting science as well. We need to gear up to defend and shield it. Shield science enterprise itself. Right now, there are efforts afoot to discredit or defund the work of scientists. So I want to call your attention to, if you're not already aware of it, the March for Science taking place on Earth Day this year, April 22nd. Those concerned are marching to Washington, D.C., and in satellite marches in cities all across the nation to encourage reliance on science in policy decisions and overall support for scientific enterprise. We are reaching out to elected officials from all political parties and encouraging scientists themselves who usually want to do nothing but do good science in their labs or in the field to get out in their communities and discuss the research they do and explain why it matters. Our speaker today is such a scientist, but one event with one audience is just barely a drop in the bucket. And the coming March is a good beginning for something more, but only that. It seeks to enlist anybody who cares about the integrity of research. That includes you. In California, planning for marches in Fullerton, Fresno, and Redding are already in motion, and there must be a Sacramento event as well. So step forward, fellow citizens. The American public today appears to lack universal recognition of the value of maintaining authentic science in our society. More than ever before, times call for ordinary citizens who value authentic science to defend it within our communities and in the media and in school curricula and programs. Citizenry with a grasp of science is the strongest defense against the unsettling future that we have on this planet, but it is becoming so obvious that we simply do not have such a citizenry in this nation. Our committee's selection of the topic of today's presentation, climate change, is indicative of that fact. While climate change is quickly gaining on us, our anti-environmental regulators and politicians still are denying the science of it and acting to undermine it at the highest levels. In conclusion, I want to acknowledge this year's co-sponsors and exhibitors, without which we could not be having a 20th annual Darwin Day in Sacramento. The outreach tablers, if they will stand when I mention them, and I don't have all of them, there were several late arrivals, but if you haven't already had time to visit all the tables, please do that. Head there immediately after the Q&A and find out what they do and why it is important to science. I began with the Humanist Association, and this celebration actually began as a project of theirs, and it remains generally so today. More recently joined by atheists and other free thinkers who are promoting civic acceptance of citizens who have naturalistic worldviews, and that is a growing portion of our population, and the National Center of Science Education in Oakland, which for the first time has not made it here today. This event has garnered endorsement by, among others, Sac State's biology and anthropology departments and the science and philosophy departments at Sac City College. We've had occasionally a business or two, electric vehicles, or today we have Solar City. Nonprofit tablers come year after year to support this event and acquaint you with what they do. Be sure to visit their tables because they help pay for the space and the refreshments. There's Americans United for Separation of Church and State, which along with the National Center for Science Education has been at the forefront in valiant efforts to keep sound science afloat in a contentious political atmosphere, and we are very grateful to them. The nonprofit Mountain Lion Foundation has returned this year, and their website is your portal to information about mountain lions and their habitat. New to this event, besides Mad Science, we have Citizens Climate Lobby, a nonprofit, nonpartisan grassroots advocacy and educational organization, and they focus on national politics to address climate change. We have Sunday Assembly, which is building secular communities across the world to help folks live more fully with the motto, live better, help others, and wonder more. There's Sacramento Splash, helping children explore, understand, and value their natural world. And Sarah, the Save the American River Association, whose members are working hard locally to protect and embrace the wildlife habitat, fishery, and recreational resources of our very own American River Parkway. We've got health care for all today. Sacramento 560. We have Explore It Science in Davis. If you haven't visited all those, do it. during the social time after the Q&A. Thank these groups for bolstering this event. There are organizations that do care about science in our community. We need more and more of them to help us with the missions of preserving science. In the current social and political context, I've got to tell you, we all have to work harder than ever to preserve sound science and as a hope for humanity. And we need allies in our desire to succeed in that preservation. They are here and they're out there. And so we need them. And in concluding, please consider to help initiate and plan a Sacramento March for Science. And next year, bring your friends, your neighbors, your family, your co-workers to our annual 21st Sacramento Darwin Day. Enjoy today.
Minga, thank you so much. How many of you were at the Women's March on the Capitol just last month? A bunch of you. And that was an amazing, powerful, moving event. Could you imagine something like that promoting science and education, right? Now, how many of you guys, you heard Minga talk about this event. It was on April 22nd, which I believe is Earth Day. How many of you think you can make it to that? That's awesome. And so you heard her. Grab your phones right now and send yourself a text or put it on your calendar or an email, whatever it is. Don't wait for us to put it on Meetup and Facebook. Just put it on your calendar right now. That's April 22nd. And we're going to see you there. I want to see you there. I want you guys to help out and be a part of this. Because you heard her, we need something like this right now. It's the climate for science and education. The forecast does not look good. So anyway, let's get on with a little bit of forecasting into our prior forecasting. I've got my book here on the origin of species. Open this up here. My little cheat sheet. I want to thank you guys for offering me the option to be the MC again. My name is David Diskin, the current president of California Free Thought Day, and it's just an honor to be here and to help advance this type of event. You know, there's so many things I could say about our speaker that we've got in, but I want to give him a chance to talk. Tom is from the USGS, the U.S. Geological Survey, the Western Ecological Research Center, part of UC Davis. He's a coastal marine biologist, which sounds like a pretty cool job if you think about it. He's got 20 years of teaching experience at UC Davis. 20 years. He's had over 150 publications. His PhD is in zoology from the University of Washington, Seattle. But his focus, if he was, I think, to narrow it down to one, is how climate change impacts the West Coast, which I'm certainly appreciative of. And so please join me in welcoming Tom Suchanek to our 20th Darwin Day.
The last 25 years I've been focusing on climate change. I was the Western Regional Director of the National Institute for Global Climate Change, Department of Energy program, and I focus primarily on marine systems, but really looking at the big picture. The big picture is the Earth. Okay, so first of all, I got more feedback here. First of all, because we're doing a little bit on Darwin, first thing that Darwin did when he went on his 5-year cruise with the HMS Beagle was to start off in England, up here, and travel all the way down to the tip of South America to Tierra del Fuego. And I just happened to, some of you know that recently I just got back from a month-long expedition to Antarctica, and this is our launching site in Ushuaia in the Tierra del Fuego region. And this is the Beagle Channel, named after Charles Darwin's ship, not his ship, but Fitzroy's ship, the Beagle. So also the launching place for a National Geographic ship, which left about the same time we did. And they are down in Antarctica now doing a special on the impacts of climate change on Antarctica. That will be broadcast on CBS News this coming week in the morning. So you might want to look at that. The other thing I wanted to talk about, or at least mention, is this little mountain right here. This little mountain is actually Mount Darwin. And that's also in Tierra del Fuego, where I just returned from. This mountain was actually named Mount Darwin for Charles Darwin on his 25th birthday in 1834 on the Beagle. So, happy birthday, Charlie. All right, let's get on with the program in hand. So what is climate change? Climate change is not a hoax perpetrated by the Chinese. It is not a scam by scientists to get more research funding, okay? So we understand that. Really, climate change is causing extreme variability. If you take nothing away but that, and we can expect, well, we can't expect it. We are experiencing unpredictable and extreme weather events. So this is going to be a theme throughout the talk. So let's take a look here. Our world is changing. Temperatures are going up. Rainfall is unpredictable. Snowpack is down. Fires are up. Droughts are up. Floods are up. Tornadoes and hurricanes are up. Sea level rise is way up. El Nino events are up. Seasonality is crazy, unpredictable. And ocean productivity is unknown. So, I mean, if anybody hasn't been living under a rock the last couple weeks or the last couple years, this last week, Wednesday, there was record high temperatures in the Northeast, 74, 75 degrees. There was massive flooding in Northeast Nevada. And the very next day, Thursday, it went down to 32 degrees and massive snowstorms and tornadoes in the South, way out of the tornado season. So we are experiencing all of these things related to climate change. All right, I probably don't need to put this up, but anyone that's been through high school probably should have understood this by now, but I'm going to put everybody on the same page before we start. Natural greenhouse effect is the sun beating down on the earth, warming the planet, and some of that radiation, some of that energy gets sent back out into space. Some of it gets trapped by what we call greenhouse gases, and the most important greenhouse gases are really carbon dioxide, CO2, N2O, nitrous oxide, and CH4, which is methane. So that's the natural greenhouse effect. The human-enhanced greenhouse effect is basically the same. It's the sun beating down on the earth, warming the earth. Some of that gets redirected back into space. But because there's increased greenhouse gases, that causes increased warming. We've known a lot about these greenhouse gases and a lot about these warming gases for a long time. This fellow in the middle, Svante Arrhenius, in the late 1800s, he was the first person to write a model describing the impact of these heat-trapping gases in the atmosphere. It took him 2 years. He did it all by hand. There was no computers back then. And at the end of the 2 years, guess what? His wife left him. I don't know what that says about us scientists, but Cindy, are you okay there? Okay, the other fact I want to bring on is that 97% of the scientists who publish papers on climate change agree that not only is global warming present and happening, but that humans are a large part of the cause. So I like to say that scientists are the map makers, and the citizens, you guys, and policy makers. I hesitated to put that in there right now, but policymakers are the navigators. We give you the information, we make the maps, and you guys do what you want with the maps. You make the policies. And right now we're kind of stuck in a place where we don't know what those policies are going to be, so we just kind of have to wait. What tools do we use to investigate climate change? Well, we use some modern evidence where we actually measure the information, and we have some historical stuff that's way prehistoric, we call proxies. So modern evidence over the past 150 years, we've measured global temperature, we've measured tide, the sea level, we've measured atmospheric concentrations of CO2 since 1958, and we've measured altered phenologies. Phenologies are just the timing of when ecological things happen. So first bud, first flowering times, bird nesting, migration data, those are all kinds of phenologies. So for the historical and the prehistoric evidence, the proxies, we can measure oxygen isotopes in marine and freshwater animal shells, tree ring data, sediment core data, ice core data. All these things are representations of what happened 100 years ago or 1,000 years ago or 100,000 years ago. And that helps us understand what will happen maybe in the future. So here's the most important greenhouse gas, CO2, carbon dioxide. Hello, there we go. Has 1 atom of carbon, 2 atoms of oxygen. And where is it coming from? It's coming from burning fossil fuels primarily, power plants, automobiles, all other kinds of combustion. And surprisingly maybe, cement production produces an enormous amount of CO2. I mean, globally it does. Where does it go?
Concrete.
I'm going to hold the questions till the end. Yes, concrete. CO2, where does it go? Plants absorb carbon dioxide in order to photosynthesize, to produce sugar, carbohydrates. And so we need to figure out how much is being produced and how much is being used. That's the global carbon budget. So here's Charles Keeling's curve. This guy started measuring carbon dioxide back in 1958 at the Mauna Loa volcano at the observatory at 11,000 feet in Hawaii. Started measuring in 1958, and these red lines are the concentrations of carbon dioxide in the atmosphere at the top, at 11,000 feet. And that blue line is the average a year. So every month, he took a measurement on the top of Mauna Loa. So this here is the annual cycle. Every dot is 1 month. And so we start here in January, is the annual cycle. And as we go through January, February, March, April, May, June, right up through here, it seems to max out. And then it starts declining on an annual basis. Well, what's happening here? The plants are growing. The leaves are out. They're sucking up carbon dioxide, literally out of the atmosphere. So the carbon dioxide in the atmosphere declines all the way down till the fall. What's happening in the fall? The leaves are falling off the trees in the northern hemisphere. Southern hemisphere is the opposite. So then, as we come to October in the fall, this starts going up again because there's much less carbon dioxide that's being taken up by the plants. So let's continue on and see what else is happening. Right now, we're a little over 400 parts per million. That number doesn't mean anything. It just means that it's higher than it was before, and it's going up and up and up. So here we are. Let's look. I mean, we were looking there at starting in 1958. So let's look a little further back. Let's look 1,000 years back, right back here. Back then, carbon dioxide concentrations were about 280 parts per million. And then, as we approached the Industrial Revolution, when we started using internal combustion engines, maybe 1750, 1800, this was starting, that carbon dioxide concentration starts going up and up and up, exponentially higher. And this is looking like a little bit like a hockey stick, and this is called the hockey stick curve. You might have heard that. All these data back here, we weren't here 1,000 years ago to start measuring. All these are from ice cores in different locations. So let's go a little further back than 1,000 years. Let's go 400,000 years back. So also using ice cores and a variety of different techniques. Right now, this last week, February 7th, we're at 406.1 parts per million, right there. And on the big scale, we're way up here. So we've gone through a variety of ice ages, and the carbon dioxide declines here when we're in an ice age, and as it increases, we have less ice, interglacial periods. And here's where man appeared on the scene about 200,000 years ago. And ice age, ice age, ice age, we're coming down from ice age. And then it starts going up again, similarly to when we're coming out of an ice age here. And here's where we started burning fossil fuels. And it just continues to go up and up and up and up, much higher than anything we've seen in the last 400,000 years. Pretty good evidence that we're doing something up there. Okay, so the global community, all the countries, all the combustion that's going on, is emitting 100 million tons of carbon dioxide each day to our atmosphere. That's about 40 billion tons last year. Now you'd say, carbon dioxide is a gas. That doesn't have any weight. Well, it actually does, minuscule amount. But when you get 40 billion tons, There's a lot of it there, and you can actually measure it. So fossil fuel emissions from burning fossil fuels like coal and oil and gas account for over 94% of the total CO2 emissions on the Earth from human sources, roughly as follows. So coal is like 42% of the contribution, oil is 33%, gas is 19%, and there's the cement plants. About 6% is actually coming from cement plants. And then actually changes in land use, like deforestation, is changing the landscape. And since there's fewer trees, there's less carbon dioxide that's being taken out of the atmosphere, so it just keeps accumulating. So there's lots of factors involved in what's happening with global climate change. So around the world, there's thousands and thousands of scientists that are collecting data, publishing reports, and trying to figure out what the heck is going on. And with all of the data that's been accumulated, they produce these, what are called assessment reports. Starting in 1990, AR1, Assessment Report 1, 2, 3, 4, 5. The last one was in 2013, 2014. And we're expected to have another one, AR6, come out in about 2018. Now, huge amount of data in here, thousands of people working on it, and they have concluded that yes, man is incredibly responsible for much of what's going on in changing of the climate. So who is emitting the most carbon dioxide on the globe? Which countries? As of 2014, we have these countries up here. That would be China and the US. Now, the US used to be producing the most amount of carbon dioxide, but about 10 years ago, China passed us out. And they're passed us out in a huge way. They have a huge amount of carbon dioxide that they're emitting from their enormous population. So the top 10 countries right here are shown account for more than 2/3 of the total global emissions that are out there. So what about per capita, per person? Who's emitting the most? Well, turns out that China is not doing that. China is way down here, number 7. But the United States is still number 2. But who's above us? Canada. Per person, Canada is producing the most amount of carbon dioxide. Interesting. So let's talk about some of the things that are happening because of climate change. Number 1 is temperature, as we've started to talk about. So here's CO2 concentrations, which are increasing, like sort of the hockey stick, starting to go exponential. And this is the long-term average of temperature. So the temperature is now starting to go up. And this is the long-term average. So before about 1920, 1930, we were lower than the long-term average. After that point, we started going up. And now from about 1970, it's all above the long-term average. Here's a different view of that with a little more data points in there. You can't see, but this is the same scale. It's just a little cut off. It's 1980 back to the present, or a little past the present. So there's mostly an increase in this curve. However, at some times, like in the 1890s, starting in the 1890s, there was a time when the temperature was actually going down. Similarly, starting in about 1940s, if you draw a line through that, you see that temperature is kind of going down. But again, if you look at the long-term trend, people like to pick those few times and say, see, the Earth isn't really getting warmer, it's getting cooler. So they pick on little time frames, but in reality, if you look at this, it's going up and up and up and going faster and faster. So what do we have here? We have the 10 hottest years, all since 1998. 2014 was the hottest year on record. Then 2015 was the hottest year on record. And last year was even the hottest year on record. That makes 3 consecutive hottest years in a row. And if we look at it more closely, that makes 39 straight years of above average global annual temperatures. And the odds of that happening randomly without global warming is 1 in 27 million. So we have 2014, 2015, 2016. 16 of the top 17 hottest years have all occurred since the year 2000. And we're only in 2017. There's only 1 year that was out of sequence there. The Earth is warming. So the heat content, where is all this heat going? Well, the heat is going mostly to the ocean. This is the upper ocean. This is 1970 to 2010. The upper ocean is accumulating most of the heat, and the deep ocean is accumulating a lot because it's circulating with the deep ocean. Ice actually holds some heat, not much, and the land actually doesn't hold a lot at all. So most of the heat, just for your information, is in the ocean. Ocean is sucking up all that heat. So let's bring it a little closer to home. Let's look at Northern California. So this is a series of model runs done by a fellow named Mike Dettinger, who's a US Geological Survey scientist. And what he did is take a look at the concentration of, the temperature, and model 23 different assumptions. So all these here things are different model assumptions based on what we think the global community is going to do in terms of reducing their carbon output. So based on these different kinds of assumptions, what's going to happen in the future? So here we are in 2017, and here's 23 different model runs. So out of the 23 model runs, 20 of those 23 are in this range, from 3 degrees centigrade to about 6 degrees centigrade. And if you don't like centigrade, I put another thing here, 5 to 11 degrees Fahrenheit is what we expect by the year 2100 if his models are, if you take the average, okay? And what that tells us is there's a strong consensus for warming in the future if his models are anywhere near correct. Let's take a look at precipitation down here. Here's 2017 again, and his model runs are running through here. And 19 of the 23 are in this range here. And they're actually, about half of them are above zero and half of them are below zero. So we have a large uncertainty with respect to precipitation. We can go long periods with droughts, we can go long periods with rain, which we might have been experiencing recently. And so the way the jet stream hits California, it's very easily tweaked, so we can get a lot of rain or very little rain. So this is not very predictable in terms of precipitation. So I just wanted to bring this up. This is thousands of years, about 12,000 years of record, in terms of the variability of temperature over time. This is about 10,000 years ago when humans started developing agriculture. This is about 4,000 to 5,000 years ago when we started building cities and civilizations. And during that entire period of time, the temperature has only varied about half a degree up and down, so about a degree back and forth. Really, what are we predicting now? What did we just say? 5 to 6, 7 degrees? That's going to send us off the chart. So in the entire time of the evolution and the development of human societies, we've never faced this, ever. Okay, let's talk about precipitation. We can have massive rainfalls, hurricanes, or we can have massive droughts, which is what we've been experiencing, some of them at the same time in different parts of the country. Atmospheric rivers. Sometimes the weathermen call them Pineapple Express. Atmospheric rivers are usually about 250 miles wide, about 1 mile high, and they come flying into the west coast of California. We only have one coast, don't we? So, well, maybe when the big one hits, we'll have 2 coasts. So the people in Sacramento probably will have waterfront property. So anyway, 250 miles wide, 1 mile high, and massive amounts of water is sent this way. And I want to show you a little video of a superstorm that happened in December of 2010. This is the video, and here's Hawaii, right here in the tropics. So all of this orange and yellow and red stuff is moisture in the atmosphere moving in towards California, and it's mostly hitting in the southern part of California. You see the ticker up here. This particular storm dropped 26 inches of rain in 5 days and 17 feet of snow in the Sierra Nevada. So one of the difficulties is that this stuff is hitting Southern California, which it often does, these atmospheric rivers. Where's all our reservoirs? Northern California. the Oroville, well, with what's just happened, the Oroville Reservoir now, if you haven't seen it, is overtopping its banks and is starting to flow, not over the spillway, but over the land, emergency spillway. So this is what an atmospheric river looks like, straight out of the tropics, straight into California. And those are more common during El Nino years. And I'm going to talk a little bit more about El Nino pretty soon. The opposite end of the spectrum, since we don't know how to predict precipitation, is the drought. This is a great tool. You can look this up, the U.S. Drought Monitor. And what you see here is that the West Coast, the western region of the country, is suffering the most. If we look at a closer view of that, here's California. Really huge, San Joaquin Valley up along the Sierra Nevada here. This D4 exceptional drought color, I was told that they had to create a new color to designate the amount of drought we're getting here. Okay, April 1st of every year, the Department of Water Resources goes up and measures the snowpack in this exact location, right there. In April 1st of 2015, that's how much snow there was. First time ever, no snow. Here's Jerry Brown, there's the Department of Water Resources guy. And over time, but there's the mark that it was the previous year, 2014, and there's 2015, nothing. So over time, we're not really able to predict much, but this year, we had massive snowstorms. And now, so the variability, again, is extremely high. If we look at the long-term trend, there's 2016 is not on there, so it would look like one of those over here, but the long-term trend, again, is down. By 2100, we're expected to lose 80% of our snowpack. That will affect a lot of businesses. Partially because of the drought, a lot because of the drought. The San Joaquin farmers are pumping a lot of groundwater out of these geologic formations. And it's not just the drought, not just the last 4 or 5 years, and we're still not out of that drought, by the way. But it's been the last couple of decades they've been doing this. Once you pump one of these reservoirs dry, the geologic formation, it collapses. And you have landmass subsidence, collapsing of the landmass. So just to give you an idea, the San Joaquin Valley floor is sinking about 2 inches per month. But wait, there's more. So here's a picture that designates what happened over the past several decades. So in So in 1925, actually, the land used to be up here. 1955, it was down here. 1977, it was down here. That is not a little plastic soldier. That is a real person, okay? And in some areas, the subsidence has been up to 28 feet, and it's continuing. Okay, we're never going to regain that landmass. What happens when we have droughts? Everything dries up, relative humidity goes down, fires go up. Beautiful sunsets, I like those. However, we're faced with a huge amount of fire damage each summer. This was August of 2016, just this past year. Massive numbers of fires. This is United States, California. Massive fires. What you probably weren't aware of is that Alaska was actually worse. It was really hit with fires big time. So you can go on this interactive wildfire tracker and home in. You can expand that map and see what each individual fire is doing. It's a really interesting place to go. So hottest years, more fires, pretty self-explanatory. As the temperature goes up, so does the frequency of the fires. Well, let's go back to something wet. SLR, that's not SNL, that's SLR. I watch SNL a lot now. Their ratings are way up. Sea level rise, for those of you who are watching too much SNL. So sea level is actually controlled by a whole host of different factors, and we don't have time today to talk about all of them. But I will simplify it by the two most important ones. Number one, about 50% of the sea level rise is coming from the melting of glaciers and ice caps, okay? The other 50%, roughly, is from seawater expansion. Now, you wouldn't think so, but as seawater warms up, it actually expands, gets bigger. And that's where a lot of this sea level rise is coming from. Simplify this, there's a lot of different things in different places that change that, but those are the two most important factors right there. Estimates, now coming more closer to home. The National Research Council in 2012 produced a report estimating the future sea level rise for California and for Washington and Oregon, all on the West Coast. So here's what they did. They did estimates for 2030, 2050, and 2100. Okay, so the orangish, yellowish bars are for California. So let's move through that. So for 2030, the estimated sea level rise might be upwards of around, 30 centimeters. That's about 0.8 feet. So for 2050, estimated sea level rise could be up to about 2 feet, which is 60 centimeters. And for the year 2100, the estimated sea level rise may be as high as 5 feet for California. So that's going to impact a lot of places, especially San Francisco and many of the other things in the South Bay. We'll talk about that in a little bit. Atolls. How many people know what an atoll is? A lot of you. Okay, well, you know that atolls are only about 6 feet above sea level. They're formed by a process that Darwin actually described, and they don't do well with sea level rise, especially if you're occupying space on one of these, like in the Maldives in the Indian Ocean. They will have a hard time getting to their grocery store if the sea level goes up 6 feet, because they're only 6 feet above sea level. They need some help. And island nations in general are in trouble, and they're already starting to plan what they're going to do. So here is the Carteret Islands near Papua New Guinea, and the Carteret Islanders have, there's about 2,000 of them, and they've already planned to move back onto the mainland of Papua New Guinea. Tuvalu, which is over here, has about 10,000 residents, and they've managed to make a deal with New Zealand where they're going to move their residents down to New Zealand. Kiribati, with about 110,000 residents, has negotiated with Fiji to occupy one of their islands. And so people are moving all around to get away from this impact of climate change. Actually, the Shishmaref Inupiaq Eskimos are on the shoreline of Alaska, and they're pretty much have been protected by sea ice. But now that sea ice is all melting and the wave action is coming in that's destroying their villages, so they're going to have to move out as well. So it's a common problem with island nations. Here we have an island nation in the Bay Area, sometimes. The ocean is not a flat surface, especially in bays and estuaries. So to show you that, the difference between Seattle and Puget Sound and Southern California is about 8-foot difference. Seattle and Puget Sound is 8 foot higher than it is down here. So similarly, in the San Francisco Bay Area, the South Bay is about 4 foot higher than Suisun Bay, interestingly. And let's see what happens if we take a look at sea level rise in the South Bay. Now, before we talk about sea level rise, I'm going to show you something else. First of all, this is the South Bay here, okay? This is Route 101, you probably know that. This is Middlefield Road that goes into Palo Alto, or through Palo Alto. And I want you to see what happens with the South Bay. With only a 100-year storm surge, no sea level rise, just a 100-year storm surge, watch the bay. Boom. That's the area that would be flooded with a 100-year storm surge. If we had a 50-centimeter sea level rise, it would then go out to this little turquoise area. 100-centimeter sea level rise, it would be in the yellow, and a 150-centimeter sea level rise, which is what I just told you about as a prediction for what California will be facing by 2100, you'll be out to the red zone. Okay? What's in the South Bay? What is it? Technology, Silicon Valley. So what do we have? We have Yahoo, Dell, Intel, none of the important people, but Intuit, Google. So I need to take a poll here. How many people own either an iPhone, an iPad, or an iMac, or Apple stock? How many people own some of these things? Not many, only about 80%. Okay, you guys are okay. Watch. There's Apple's campus in Cupertino. You're safe. Keep investing in Apple. My son works for Apple, so it's okay. Thanks. All right, let's talk about upwelling and El Nino. It's getting more and more obvious that upwelling is happening, but El Nino events are happening more frequently. So what does that do? Here's a little phrase that I heard one time. The coldest winter I ever saw was the summer I spent in San Francisco. Who the heck would say that? Mark Twain? Oh, no, there he is. Okay. And why is that? Why was it so cold? The wind. The fog. You're both right. Wind and fog. Okay, let's see what's going on with that. Yes, the fog. Well, it turns out that the fog is really important to the redwoods. The entire forest depends on that, and all of the species in that forest depend on the fog. So it's really a regular process. It happens from about March or April, all through the summer, down to about August. You get, and how that happens is we have strong northerly winds that are blowing down the coast, and what happens is because of the spinning of the earth and the Coriolis effect, that water is moving out to the open ocean. It's from the land, the surface water is moving out. What happens then is that deep water comes up to replace that water that's missing on the surface. And that water is cold, and it's very nutrient rich. So when the cold water hits the warm air, you get fog. And that's why San Francisco is the way it is in the summer, is because of coastal upwelling. Well, the fog is important to the redwoods, but the nutrients are also important for a whole nother community in the ocean. And that is, the nutrients provide food for phytoplankton, which are these microscopic plants that are being eaten by microscopic animals, which are being eaten by small fish, which are being eaten by large fish, which are being eaten by marine birds and mammals. And it produces a whole productive marine community every year, except during those years when we have an El Nino event. When we have an El Nino event, those winds stop, and the water doesn't go out to the ocean, and upwelling stops, and we lose the nutrient-rich water, we lose the phytoplankton, the zooplankton, the small fish, the large fish, and we have a crash during El Nino years. That affects fisheries, it affects recreation, the huge influence, and El Nino events are becoming more and more common because of climate change. OA, what's that? What is it? Okay, sorry. Let's just get on with it. Ocean acidification, we're number 3, we're having fun. All right, the ocean absorbs about 1/4 of all the global carbon emissions that are out there. Here's that same graph, the up and down that we talked about before, all right? Charles Keeling curve. So if we look at this, this is the atmospheric concentration of carbon dioxide. And here, because that's at the surface of the ocean, here's the ocean surface, it's absorbing that carbon dioxide, it's also going up. And as the surface goes up and more concentration of carbon dioxide in the ocean, pH goes down. And if you remember your chemistry class, pH, the lower the pH, the more acid it is, okay? So as carbon dioxide goes up, both on the atmosphere and the ocean surface, the pH goes down, which means it becomes more acidic. Marine animals have to get calcium carbonate from somewhere to build their shells, whether they're little larvae or whether they're adults. They have to get, and they pull that out in the ionic form, and they create their shells from that. So, decreased pH lowers the saturation of calcium carbonate in the seawater. It makes it much more difficult for those marine organisms to pull that out. So, what we have here, all those things that you like to eat, oysters, abalone, scallops, starfish, oh no, you don't eat starfish. Anyway, by the end of this century, it's predicted that the ocean surface will be more acidic than it has been in 400 million years. That's going to make it pretty tough for these guys to build shells in the future. So, where do we go from here? Paris. Okay, let's go to Paris. A lot of people went to Paris in 2015 for the climate summit in Paris. That was called the COP21, which is the Conference of the Parties for the United Nations Framework Convention on Climate Change. They have this every year, and that was the 21st meeting or Conference of the Parties. It occurred in December of 2015, and its goal was to develop an agreement whereby the international community would work together to keep global warming at or below a 2 degrees centigrade or 3.6 degree Fahrenheit increase from above pre-industrial levels, which is whatever you want to say, 1750 or 1800. We don't have time to talk about where that 2 degrees increase came from, but we're trying to keep it below 2 degrees centigrade. Now, there were 194 countries that participated in that process, almost all the countries in the world. And as of November 4th, a couple months ago, the Paris Agreement was entered into force. They did an agreement. That was the agreement that President Obama helped develop. His administration had a huge influence on developing that agreement in Paris. And it was agreed to and entered into force by 116 of those 194 countries, which made up at least 55% of the total global greenhouse emissions. They've agreed to do that. Now, last year's COP22 was in Morocco. This year's COP23, 2017, is going to be in Germany in December. So keep your eyes open and listen to see what's happening there. So as a result of that, there are now predictions for what we can do with the agreements from the Paris Agreement, with the pledges that were made. So here's a figure. So this is greenhouse gas emissions, and here's temperatures as a result of that. So right now, okay, this is warming projected by the year 2100, and right now we are in this gray zone. So if we do nothing, if we continue on the way we're doing right now, we can expect that, here's centigrade and here's Fahrenheit, we can expect that we will reach, by the year 2100, we will probably reach 4.8 to 8.6 degree Fahrenheit increase in temperature. Because of the Paris Accord, or Paris Agreement, I'm sorry, blank that, current policy projections based on not the Paris Agreement, but just where various countries are planning in the future right now, would send us in this blue zone, which would be about 5.9 to 7.0 degrees Fahrenheit. Now, the pledges and the promises that were made at the Paris Agreement is in the red zone here. That would probably bring us up to about 4.5 to 5 degrees Fahrenheit. That's still over the 2 degrees centigrade. And here's where we kind of wanted to be, is in this little mustard colored thing, 1.5 to 1.7 or below 2 degrees centigrade. That's still 2.7 to 3.1 degrees above. And what we'd really like to get at, the way the Paris Agreement was established, is below 1.5. That's not going to happen. In fact, it's probably not going to happen that we're going to keep it below 2 degrees centigrade. So we're going to try everything we can to encourage those countries who made pledges to honor those pledges and reduce their carbon dioxide emissions. Now, I don't know how easy or how hard it's going to be to do that. The big elephant in the room is obviously the problem that he doesn't believe in global warming. I don't know where that's going to send us, but he has threatened to disavow the Paris Agreement. With 116 countries involved in this signatory, I think that's going to be hard to do. We'll see what happens. But he says nobody really knows if climate change is real. And he's studying whether the United States should withdraw from the global warming agreement struck in Paris a year ago. You know, we have to wait and see, but I think it's going to be difficult to pull out of that. I hope it's going to be difficult. Discouraging also, the moment Trump took office, the official White House website was purged of all references to global warming and climate change science. Very disturbing. I'm concerned. So what we need to do is we need to get off fossil fuels. There's all kinds of alternative energy sources that we can use. Many of them are in process now. This past year, we've reached a point where the technology for all of these other options, solar, wind, hydro, tidal, wave, currents, geothermal, have surpassed fossil fuel options, okay? Not using them, but just the capability and the options for them. Solar, we're not doing much with solar. China is huge. They're the first in the world with solar right now. Wind, Germany is #1 in the world. They're doing great things. And we have options here. So we need to encourage our policymakers to look at other options. California is definitely a global leader. Any of you who have watched this and have followed it, in 2006, the legislature in California, Assembly Bill 32, Global Warming Solutions Act, established a program to reduce California greenhouse gas emissions to 1990 levels by the year 2020. Don't worry about the red part. Now, this last year, 2016, Senate Bill 32 added to that and says it goes further by reducing greenhouse gas emissions to 40% below 1990 levels by 2030. No other state is doing that. We are definitely the world's leader on this. So what can we do to help? We can do things at the global level, national level, state level, local level. We can do things at all kinds of levels. So from a bigger picture, what can we do? We need to reduce our use of fossil fuels. That's the biggest thing that we can do. Or vote or contribute to your local, state, national representatives to whatever things concern you the most. And that's important. Help make environmental education mandatory. What can we do locally? We can eat lower on the food chain. It uses less energy, produces less carbon dioxide. Reduce, reuse, recycle everything possible, especially plastics that are made from fossil fuels. Use EPA's household carbon footprint calculator. That'll tell you how good or bad you're doing in terms of producing carbon dioxide. Drive an electric or hybrid car, or use alternative transportation, or use a carpool. Anything like that would help. Use a programmable thermostat in your house. Use Energy Star products like washing machines or dishwashers or refrigerators. They save a huge amount of energy. Don't leave your car idling. Turn off unused lights. Remember, local actions have global consequences, okay? So, the bottom line, I think I've given you a smattering of various different things associated with climate change. It's a really complex topic, and I've just given you little tidbits of this. But I think with all the research that all the scientists in the world are doing, we've finally found the answer and proof of global warming. Thank you. Yes.
First, thanks a lot for your talk. I learned an awful lot, and it was very worthwhile.
You're welcome.
My question has to do with supposedly zero pollution electric cars. What about the battery factories? I would hate to live in one. I've never read how much pollution is coming from them.
So the question is, what about zero emission cars, and how do you figure in the components of the battery to the emissions and all of the things that go into making the car? Is that correct? Okay. So when you have a zero emission car, what that's saying is it doesn't pump out carbon dioxide out of the tailpipe. There's lots of things that went into the manufacture of that car that clearly are producing carbon dioxide. And you have to believe that that's probably equivalent to, or in some ways equivalent to, production of a fossil fuel burning car, but the advantage is that it doesn't continue on year in and year out to then pump more carbon dioxide out the tailpipe. So yes, you're right, it does produce carbon dioxide in the manufacturing process and in the batteries as well. But we're hoping that slowly but surely we can stem the tide and reduce carbon emissions. Anybody else?
Yes.
Where are we?
Just on the other side of that speaker.
Can you go into a little bit more about the high per capita that Canada is producing on carbon emissions?
So the question is, what about Canada? Well, I actually don't know a lot about why Canada is producing that much. Maybe a lot of Americans are going up there because of various different reasons. Not sure, because I really don't know. I'm sorry. Next. Anybody else? Oh, okay.
Yeah,
Go ahead.
move this over so I can see.
Yeah, okay, there we go.
So we've got the CO2 level rising in the Keeling curve, and it seems like to get to 1.5 degrees or to stop at 2 degrees of global warming, we'd actually need to stop all CO2 emissions. So to,
The question is you turned me off, didn't you? Is the question, can we turn off all CO2 emissions? Is that the question?
well, is that required to limit global warming to any degree level?
No, it's not. It's not required to bring down any level of CO2. All of those things that I listed up there are ways that we can reduce CO2. The manufacturing element of our society produces an enormous amount of carbon dioxide. During various different global events, like the savings and loan crisis, the various things that happened which kind of brought the marketplace down, brought the carbon dioxide level down at the same time. So it's stunning how much of an influence those small events could have on lowering carbon dioxide. Obviously it's not possible to stop production of all carbon dioxide. Even the United States should be a leader in this. We have the technology, we have the resources, the economic resources, we have the intellectual resources, we have the manufacturing capability to transform our entire economy into alternative energy sources. So we can do a lot to do that. We should be a leader in the world showing other countries how to do that. But in terms of stopping, CO2 production, we just simply can't do that. But the agreements that were made in Paris would do a lot to bring those down. The question is, are they going to uphold those pledges? That's still questionable, because they still have, another 10, 15 years to go. Now, whether they will actually do that or not, they're only pledges. Nobody's going to police them, unfortunately. There's no penalty for not doing it, and that's the problem. So we need to have, better and better technology. We need to go off of fossil fuels onto alternative energy sources, and with that, we can then hopefully bring it down as much as possible. Now, maybe we'll reach the 4 or 5 degree level and not the 2 degree level, but we just need to do what we can, and we can do a lot. We just need to get our policymakers to do the right things.
Yeah, I wonder actually about the IPCC report that has a summary for policymakers. I wonder if they couldn't have a summary for individuals and give us a graph of the pounds of CO2 per day we each can emit, and then meet these requirements like you suggest.
Okay, so the question is that IPCC, the Intergovernmental Panel on Climate Change, which produced all these reports, he's asking if they could produce something that shows how much each carbon dioxide each individual produces, and then we could monitor ourselves. That executive summary that they produce actually is a really good summary. That's a really good summary for the layman. So I would encourage anyone who's interested in the fine details of carbon dioxide, how much you are producing and how much you are producing, go to carbon footprint. Go to the carbon footprint calculator and see for yourself, okay?
Go ahead and stand just right here, and then you'll be able to see her. All right, you mentioned that Trump is denying climate change in your presentation. Yeah. What can I do when he's not accepting climate change as a reality? What can I do personally?
There you go.
What else can I do?
The comment was, since Trump is not believing in climate change, what can each individual person do that may influence this process? Well, you could have not voted for Trump in the first place. Anyone, I'm assuming that you didn't vote for Trump. Don't mean to assume anything here. But the problem I'm seeing and the concern that I have is that many of the appointees, many of the people who he was appointing seem to have been or verge on, they were climate deniers. And the problem is that now that the election is over and now that the administration is in place, they seem to have changed their tune. Now they're sort of admitting that climate change is happening and it may be related to humans and it may not. So now they've turned from deniers to skeptics, and I really don't know what they're going to do. With Rex Tillerson as the new Secretary of State, a long time ago he said he believes in climate change. He believes we should have a carbon tax. Okay, good for him. But I think the proof is in the pudding. We really need to wait and see what they're going to do with the new administration, with Rick Perry, with Scott Pruitt, with all these people who are going to head up the Energy Department, the EPA, if it still exists, and all these other things. We need to wait. I'm willing to give them the benefit of the doubt. I'm concerned, but what can you do? I think you should get concerned. You should write and keep writing and keep calling to your representatives, local, state, national representatives. For Trump, certainly the national approach. And express your opinion, express your concerns. Every time something happens, shoot another email, make a call, keep the pressure on. That's what you can do. Join the march.
All right,
Donate.
we have time for 3 more questions right over here. Go ahead.
Thank you for your talk. Since apparently climate change is not a hoax, is that your premise?
I'm getting there. I'm getting there.
But I have another question, because the young lady asked the question I really wanted to ask was how can we activate? Now, I belong to Union of Concerned Scientists, and there seems to be a lot of criticism of science, especially in this current administration. And how can we as citizens and those that are not scientists bring the truth out in terms of these people accepting science as opposed to fake science, I guess might be a better way to say that. And also, is there a difference scientifically between the terms climate change and global warming?
Okay, 2-part question. What can we do to stem the tide against the administration who is saying that they don't believe in climate change? Well, again, the same answer that I gave the other gal. Contact your representatives in Congress, write to them, phone them, contribute to the various causes that that are important to you. March, donate, be an advocate for the environment in every way you possibly can. I gave a whole bunch of examples there. The second question was, what is the difference between global warming and climate change? Global warming is an artifact or a result of climate change. Global warming is at the root of climate change. So you can use global warming, you can use climate change. It's all part of the same process that we are experiencing because of increased atmospheric greenhouse gases. That's all it is. You can call it what you want. The result is the same. Yes, 2 more.
Thank you very much for the talk. You seem to be preaching to the choir here. I wonder if you've been involved in debates with people who do not accept the data and presentations you've just given us today, and what was the outcome?
Good question. What was the outcome of any debates I've had with people who do not believe in climate change? Well, I have been in some debates, but I would say that it's very difficult to change many of the people's views who are climate deniers or even climate skeptics. However, on the other hand, I have changed some people's minds occasionally. And once they understand what it's all about by watching one of my presentations, they said, oh, wow, oh, that's really, wow, I didn't realize that. And then I give them some references and they go back and they actually read it, read the true facts instead of fake news. Then they actually start coming around. So there have been some successes, and there have been mostly not successes. One more.
Hi, thank you for speaking with us today. My question was partially asked by the previous person, but I was wondering if you ever get asked to speak at organizations that do not believe in climate change.
Not yet. I would wear my bulletproof vest if I did that. So thank you all for coming. I appreciate you being here.
Dr. Suchanek, thank you so much.
If anybody else wants to ask questions or discuss things with me, I'll be around for a while. So help yourself.
Great, thank you. We're going to wrap this up in just a few minutes, so don't quite get out of your seats just yet. I want to bring back Minga onto the stage, who has a couple more brief announcements, and then we're going to sing happy birthday, right? So just get those vocal cords warmed up. Minga, it's back to you.
Is this on? Hello. I have a real quick comment. I've been at this for a while, and I decided, and the committee decided this year, that we definitely are tired of crowds that don't fill all these chairs, and we want to double it and triple it for next year. So I'm bringing on board a new chairman who's really going to roll up his sleeves and promote us. He's a promoter type. We need a promoter type to get more people involved, so we're not preaching to the same choir each year. So I want to introduce, where are you? Pat Desmond, who's helped us a lot this year, and he's going to give you some instructions for next year.
Thank you, Minga. Hi, my name is Patrick Desmond. How many people here are scientists or in the science community? Raise your hand. Well, thank you very much. How many people are friends and fans of science? That's me as well. That's really heartening. I didn't know that. I expected more people to be scientists. So that's my goal. Minga's set a very high bar. She's been doing this for nearly 20 years, one of the first Darwin days in the country. I'm just an advocate of science. I believe in it very much. I came late to the game. I want to do everything I can to promote science in my community. I also would like to try to promote some diversity and some young people into the room. And I think we can do that together. I see a lot of young leaders in the room already. And I invite you to invite friends next year. I've got my little sign-up sheet. We've never really gathered attendees' information before, so we're going to start there and just get on our mailing list, and we'll let you know what we're doing and when we're doing it and that sort of thing. But I really love this event just the way it is. No big plans to change it a whole lot, other than to try to get some more diversity and young people in. I think having Access Sacramento here today, all their hard work is going to help a lot. So I want to give them a big hand and thank them again. Apparently this program will be available in 3 or 4 weeks. It'll be broadcast on Access Sacramento. So look for it and share it. We'll do the social media thing. We'll just try to hashtag this thing and make this event a lot more fun. It's a really fun committee to be on if you'd like to be on the committee. It's very nice people, hardworking people. I've enjoyed it very much. We're going to keep it going like that. But before we go any further, I just want to take a minute to recognize Minga. She's set a great example, and we have a little token of appreciation for her. Minga, you're a wonderful person. She has a perfect combination of seductress and taskmaster that I'm not sure I can emulate. I'll try to bring my own style, but I'm really proud to get to know you, and you've built a wonderful thing here, and we're going to keep it going as long as we can. So thank you very much. Okay, let's back to David. Thank you again, David. We're going to keep David here as long as we can. He brings a lot to the table, and his organization. Support David's organization as much as you can. Free Thought Day is a very important day, So we're all friends here. Let's get together every year and have a birthday party.
Pat and Minka, thank you so much.
Yeah, and sign up here if you see me. Sign up.
All right, so in addition to signing up for next year's Darwin Day and getting on what was that day that we were talking about earlier when we're all going to march on Sacramento about science? What day is that? All right, all at once. 1, 2, 3, go. Excellent, good. Okay, with that out of the way, it's time to pay our respects to Mr. Charles Darwin. I'm going to turn off the mic because you don't want to hear me sing. You are all going to join me in this, though. Don't make me be... All right, so on the count of 3, we're going to sing Happy Birthday to Charles. Not bad. Not bad at all. I want to thank all the sponsors, all the volunteers, all the exhibitors, everybody who was a part of this event, especially Minga and the committee. If you haven't yet, please check out all of these great folks surrounding the entire room. There's Darwin Day merchandise, including mugs and Darwin finger puppets and all kinds of stuff that Ruth has over there. And yeah, so in the back, we've got refreshments, we've got cake, we've got vegan cake and all kinds of other cool stuff there. Thank you all so much. I hope you had a great Darwin Day. I wish you all a wonderful Valentine's Day. I will see you when? April 22nd, Earth Day. Thank you, and happy birthday to Charles.